Gravity. It's the force that keeps our feet on the ground, holds the planets in orbit, and shapes the very structure of the universe. But have you ever wondered how humanity came to understand this invisible force? Today, we're going to travel through time, from ancient myths to modern discoveries, unraveling the mystery of gravity. So grab an apple, or at least imagine you're Newton under an apple tree, and let's dive into the fascinating history of gravity. Part 1. Ancient Ideas of Gravity. Let's start with the ancients. Thousands of years ago, humanity looked up at the stars and saw order. The stars, planets, and the sun moved across the sky in predictable patterns. This cosmic clock led ancient civilizations to believe in a structured, purposeful universe. One of the first to ponder gravity was the Greek philosopher Aristotle. In his mind, everything had a natural place. Rocks belonged on the ground, and fire belonged in the sky. He believed heavier objects would fall faster than lighter ones, thinking it was common sense. Little did he know that this was only the beginning of our quest to understand gravity. Part 2. Galileo's breakthrough. Fast forward to the late 16th century, when a curious Italian named Galileo Galilei challenged the ancient wisdom. Legend has it, he dropped 2 balls of different weights from the Leaning Tower of Pisa and discovered something shocking. They hit the ground at the same time. Galileo's experiment revealed a powerful insight that gravity pulls all objects equally, regardless of their mass. This shook the foundations of centuries-old beliefs and paved the way for the greatest gravity theory of them all. Part 3. Newton's revolution. Enter Isaac Newton. According to the famous story, Newton was sitting under an apple tree when, thud, an apple fell. This seemingly mundane moment inspired him to ask, why did the apple fall straight down? And why does the moon stay in orbit? Newton connected the dots in a groundbreaking way. He realized that the same force pulling the apple down was keeping the moon in orbit. This was the beginning of Newton's law of universal gravitation, the idea that every mass in the universe attracts every other mass. Newton came up with a formula to express this force, using 3 factors: the masses of the 2 objects, the distance between them, and a mysterious constant we call g. This formula described how everything in the universe interacted, from falling apples to orbiting planets. Newton's law was so powerful, it allowed us to predict the movements of planets and even the orbits of comets. Newton's theory reigned supreme for centuries. It was elegant, precise, and simple. But as our understanding grew, we started noticing little cracks in Newton's theory. And that's where our next revolutionary mind comes in. Part 4. Einstein's relativity. In the early 1900s, a young patent clerk named Albert Einstein began questioning the nature of gravity. Why should 2 objects attract each other across empty space? To Einstein, it didn't make sense. Einstein started imagining gravity as more than just a force. In 1915, he published his general theory of relativity, turning our understanding of gravity upside down. In Einstein's view, massive objects like planets and stars actually warp the fabric of space and time around them. And what we feel as gravity, it's just objects following the curves in this fabric. Imagine space-time as a giant trampoline. Place a bowling ball on it, and the trampoline bends. If you roll a marble nearby, it'll spiral toward the bowling ball, not because it's attracted to it, but because the trampoline's surface is curved. Einstein's theory also led to the discovery of black holes, regions of space where gravity is so strong that not even light can escape. This warped reality changed how we saw the universe. Gravity was no longer a force, but a feature of space-time itself. Part 5. Modern research, quantum gravity and dark matter. Today, scientists continue to study gravity. But here's the twist. When we look at gravity on tiny scales, at the level of atoms and particles, Einstein's theory doesn't hold up. This is where quantum mechanics comes in, with its strange and mind-bending rules. Physicists are trying to create a theory of quantum gravity that unites Einstein's relativity with quantum mechanics. Imagine 2 puzzle pieces that almost fit, but not quite. Scientists are still working on this mystery, but a complete theory could change our understanding of the universe itself. And then there's the mystery of dark matter. When we observe galaxies, they behave as if there's extra invisible mass. This dark matter doesn't emit light, but its gravitational effects are undeniable. It's as if there's a hidden skeleton of gravity holding galaxies together. From the ancient Greeks' natural order to Newton's universal laws and Einstein's warped spacetime, gravity has always been the force shaping our understanding of the cosmos. Yet the more we learn, the more questions arise. So next time you see an apple fall, remember, it's not just falling, it's a part of an intricate cosmic dance, guided by the mysteries of gravity. If you enjoyed this deep dive into gravity, hit that like button, subscribe, and let us know in the comments, which part of gravity's story surprised you the most? Until next time, stay curious and keep looking up.